قبل 100 عام كشفت معادلة توحي بأنها بسيطة عن وحدة خفية مدفونة عميقا في نسيج الكون. إنها تحدثنا عن علاقة مدهشة بين الطاقة والمادة والضوء. مكتشفها هو الشاب ألبرت اينشتاين. إنها أشهر معادلة في العالم. الطاقة تساوي الكتلة ضرب مربع سرعة الضوء. مع أن معظمنا سمع بفكرة اينشتاين الكبيرة، فإن قليلين منا يعرفون معناها. في الحقيقة معادلة الطاقة تساوي الكتلة ضرب مربع سرعة الضوء بالغة الأهمية، لدرجة أن اينشتاين نفسه ما كان واثقا من صحتها.
Albert, darling, you're later than I expected. We've only got sausage and cheese tonight. What is it?
We need to talk.
Has something happened?
Oh, no, nothing. Sorry, no. I spent most of the day staring out the window at work, looking at trains. And I started to think about an object and how much energy it had. Can I explain it to you?
Of course you can. But first, dinner. Food and talk.
I think the gods are laughing at me.
لم تكن أي قوى تسخر من اينشتاين. لقد استحوذت عليه رؤية مذهلة، عمل خاض فيه العديدون قبله. علماء كافحوا وعلماء ماتوا للتوصل إلى بعض أجزاء المعادلة. إن حكاية المعادلة بدأت قبل اينشتاين بمدة طويلة، مع ظهور حرف طاء كرمز للطاقة. في بدايات القرن 19 لم يكن العلماء ينظرون إلى المسائل من خلال الطاقة. كانوا ينظرون إلى الأشياء على أنها قوى منفصلة، قوى منفصلة إحداها عن الأخرى وغير مترابطة. قوة الريح، قوة إغلاق الباب، قرقعة البرق. فكرة أن يكون هناك نوع من الطاقة الرابطة بين القوى لم تكن قد اكتشفت بعد. جهد شخص واحد سيؤدي إلى تغيير فهمنا بهذا السر الغامض في الطبيعة.
Young Michael Faraday hated his job. He was uneducated, the son of a blacksmith. He'd been lucky to become a bookbinder's apprentice. But Faraday craved one thing. He craved knowledge. He read every book that passed through his hands. He developed a passion for science. All of his free time and his meager wages were poured into his self-education. He was on the threshold of an incredible journey into the invisible world of energy.
أثار فاراداي إعجاب أحد زبائن سيده، وكوفئ ببطاقة غيرت مجرى حياته.
Can I pass, please? Can I pass? Some of us are trying to improve ourselves. If people will let us.
Of course. Pass. This way to a better life.
In the early 1800s, science was a pursuit of gentlemen, something Faraday was clearly not. He had a rudimentary education. He'd read widely. He'd gone to public lectures. But in 1812, he was given tickets to hear Sir Humphrey Davy, the most prominent chemist of the age.
كان علماء القرن 19 نجوم عصرهم. كانت محاضراتهم ذائعة الصيت، ومن الصعب الحصول على بطاقة دخول لحضور إحداها. كان ديفي منتشيا بمكانته. وكان متابعا دقيقا لآخر مكتشفات أكسيد النيتروجين أو الغاز المثير للضحك. كان يقول إن فيه كل خواص الكحول من دون آثاره السلبية.
Electricity, ladies and gentlemen, a mysterious force that can unravel the confusing mixture of intermingled substances that surround us and produce pure elements.
Davy was an absolutely first-rate scientist. However, many will come to say that his greatest discovery is Michael Faraday.
Metals unknown, that is, until I isolated potassium from molten potash and sodium, as I showed you last time, from common salt. That same magical
لم يكن فاراداي من النبلاء. لكنه ما كان ليسمح للحواجز الطبقية أن تقف دون تحقيق طموحاته العلمية. عمل ليل نهار ليجعل ملاحظات المحاضرات بين دفتي كتاب من أجل بطله الجديد.
Lord, help me to think only of others, to be of use to mankind. Help me be part of the great circle that is your work and love. Lord, I am your servant.
Well, this is excellent work, Faraday. So what is it you aim to do with your life?
My desire, sir, is to escape from trade, which I find vicious and selfish, and to become a servant of science, which I imagine makes its pursuers amiable and liberal.
Really? Well, I shall leave it to the experience of a few years to set you right on that score. Look, I haven't done anything at the moment. I'll send a note if anything comes up.
على الرغم من هذه الانتكاسة المذلة، قرر فاراداي التخلص من الكدح اليومي، وتكلل سعيه بالنجاح.
Newman, meet Mr. Michael Faraday. He's going to be my helper while I recover. He assures me he is a Christian fellow. Perhaps with God and Faraday in charge of the chemicals, you and I will be safe in our place of work.
Thank you, Professor Davy. Welcome, Faraday.
Oh no, thank you, and thank you, Sir Humphrey.
Just stick to your job and do as you're told, and you'll be fine, Faraday.
أصبح فاراداي مساعدا مخبريا يهضم بشغف كل معلومة يتلقفها من ديفي. لكن مع مرور الزمن استطاع التلميذ أن يتفوق على أستاذه. الكهرباء كانت صرعة تلك الأيام. لقد تم اختراع البطارية وأجريت كل أنواع التجارب، لكن أحدا لم يكن يدرك معنى القوة الكهربائية.
The academic establishment at the time thought that electricity was, like a fluid flowing through a pipe, pushing its way along. But in 1821, a Danish researcher showed that when you pass an electrical current through a wire and place a compass near it, it deflected the needle at right angles.
كانت تلك أول مرة يشاهد الباحثون فيها تأثير الكهرباء في المغناطيس. أول لمحة لقوتين كان يعتقد أنهما منفصلتان، وتبين أنهما متحدتان بطريقة لا تفسير لها.
Faraday, come look at this. Another bright spark around here. Perhaps you can work it out. Ersted's reported an amazing finding. We're just replicating it here.
Let's try the compass on the other side.
Now, that is remarkable.
But if the electrical force is flowing through the wire, why does the needle not move in the same direction, parallel to the wire?
Quite.
Let's try turning the whole apparatus round.
Again, Newman.
So, the electrical force goes this way, the compass points that way. How can one affect the other?
Perhaps the electricity is throwing out some invisible force as it moves along.
What?
Perhaps some sort of electrical force is emanating outwards from the wire.
Oh, my dear boy, let me tell you that at the University of Cambridge, electricity flows through a wire, not sideways to it.
Well, that may be what they teach at Cambridge, but it doesn't explain what's happening before our eyes.
No, let's just get on. Let's swap the compass to below the wire.
لماذا انحرفت البوصلة نحو القوائم اليمينية؟ لماذا أثرت الكهرباء في البوصلة أصلا؟ هذا ما أذهل ديفي والآخرين.
As we celebrate the marriage of Michael and Sarah.
بالنسبة إلى فاراداي قضت المشكلة مضجعه، كأنها إلهام من الله. كانت المشكلة بالنسبة إليه طريقة لفهم معجزات الله.
There was a small, almost persecuted group in London called the Sandemanians. They were religious, not really a sect, they were just a small subset, sort of like Quakers. Faraday was a member of that group. It was a very gentle, decent group. They believed that underneath the whole surface of reality, everything was created by God in a unified way, that if you opened up one little part of it, you could see how everything was connected.
Michael Faraday was someone who, like Einstein, thought in terms of pictures.
Faraday was different from anybody else. He had a flair for understanding his experiments, for understanding what was really going on inside them.
عندما حرك فاراداي البوصلة حول السلك بدأ يلاحظ نمطا معينا.
What everyone else at the time had been taught was that forces travel in straight lines. Faraday was different. Faraday imagined that invisible lines of force flowed around an electric wire. And then he imagined that a magnet had similar lines emerging from it, and that those lines would get caught up in this flow. It was a bit like a flag in the wind.
لكن قفزة فاراداي الكبرى كانت في قلب التجربة رأسا على عقب، فبدلا من أن يحرك السلك المكهرب إبرة البوصلة تساءل إن كان في وسع المغناطيس الساكن تحريك السلك.
I've never seen you like this, Faraday. You look like a happy child. I'm shaking, Newman. Underneath, I'm shaking. You see, John? You see? Yes.
This is the experiment of the century. It's the invention of the electric motor. Scale up the magnets and the wires, make them really big, attach heavy weights to them, and they'll be dragged along. But almost more importantly, he's inventing a new kind of physics here.
مع أنه لم يدرك الأمر في البداية، فإن فاراداي عرض مبدأ التقويس، وهو تحول المواد الكيميائية في البطارية إلى كهرباء في السلك التي اتحدت مع المغناطيس لتنتج الحركة. وخلف كل هذه القوى كانت هناك الطاقة العادية.
A couple of months earlier, Davy had been elected president of the Royal Society, which was the elite body of English science. But then he saw this great discovery published in the Quarterly Journal of Science. I don't know if he was envious, but he certainly saw that this young man who had been his assistant, this mere blacksmith's son, had come up with one of the greatest discoveries of the Victorian era.
Davy accuses Faraday of plagiarizing similar work from another eminent British scientist, William Wollaston.
So, Faraday, what does Wollaston make of all this?
He's written to me and assures me that he's taken no offence. And he acknowledges that what I published was entirely my own work.
Right. Davy is just being an ass.
But will Davy now retract his allegation?
Sadly, no. In fact, he's still vehemently opposed to you being elected a member of the Society.
Really? And what do you think?
Faraday, my dear boy, you have my vote.
And mine. And I believe you even have Wollaston's.
What a mess.
Well, no matter. It's the science that counts. So tell me, how does this wire of yours spin round its magnet? What mysterious forces are at play?
There seems to be an electromagnetic interaction. In my mind, I see a swirling array of lines of force spinning out of the electrified wire, like a spiraling web.
But invisible lines of force, it's all a bit vague, isn't it?
Faraday, might I have a word in private?
Certainly.
Listen, Faraday, let's stop this nonsense. I want you to take down your ballot paper from the notice board.
Sir Humphrey, I see no reason to take it down. My friends have proposed me. It is they who put the paper up. I will not take it down. Good day.
تم انتخاب فاراداي عضوا في الجمعية الملكية، وتوفي ديفي بعد 5 سنوات نتيجة استنشاق الكثير من الغازات. ومع مرور الزمن أدت بحوث فاراداي حول القوى غير المرئية إلى فهم جديد للطاقة. أطلق ما يسميه اينشتاين الثورة الكبرى. في قلب عالم الطاقة المثير هذا نشأ اينشتاين.
My father and uncle wanted to make their fortune by bringing electric light to the streets of Germany. From an early age, I loved to look at machines, understand how things work.
He's going to kill himself.
Albert, stay there.
I experienced a miracle when my father showed me a compass. I trembled and grew cold. There had to be something behind objects that lay deeply hidden. At high school, they had their ideas about what I should learn. I had my own. I was merely interested in physics, maths, philosophy, and playing the violin. Everything else was a bore.
Einstein! On your feet! As you obviously know everything about geology, tell me, how does a rock start run here?
It's pretty much the same to me whichever way they run, Herr Professor.
حاول أساتذة اينشتاين أن يدخلوا في رأسه كما حصل مع فاراداي أن الطاقة يمكن أن تتحول من شكل إلى آخر. كانوا يعتقدون أيضا أن كل أشكال الطاقة قد تم اكتشافها. كان اينشتاين يحاول إثبات الخطأ الذي تسببوا به. سيكتشف أن خزانا هائلا جديدا من الطاقة مخفي في مكان لم يخطر في بال أحد من العلماء، عميقا في قلب المادة. قبل 100 عام من ولادة اينشتاين كان الملك لويس الخامس عشر على عرش فرنسا، لكن السلطة الملكية المطلقة على الشعب كانت قد بدأت تواجه التحديات. الثورة الفرنسية كانت على الأبواب.
This was the era of enlightenment, when intellectuals believed very firmly that the way forward lay in science. And they felt that one of the first tasks that lay ahead of them was to rationalise and to classify every single kind of matter so they could see how it all interacted together.
قرر أنطوان لافوازييه الشاب الأرستقراطي الثري أن ينكب على هذه المهمة لمعرفة ما إذا كانت هناك صلة جوهرية بين جميع الأشياء وعناصر الحياة اليومية في العالم. لكن ما ساعد لافوازييه كعالم هو اهتمامه الدقيق بالتفاصيل، وهو أيضا ما أدى إلى سقوطه.
Monsieur Lavoisier, you are, if my eyes do not deceive me, consuming only milk this evening. First you had a glass of milk, now you are eating a bowl of milk. Will you next move on to a plate of milk?
Your precise observations commend you as a lady of scientific curiosity, mademoiselle. Most unusual. As you seek knowledge, so I shall dispense it. For the last 5 weeks, I have taken nothing but milk.
Good God, man. I would rather die than fast on milk for 5 weeks. Are you in the grip of some horrendous ailment?
On the contrary, I am investigating the effects of diet on health.
Monsieur, with the greatest of respect to a member of the Royal Academy of Sciences, your gut must think your throat has been slit.
Whereas your gut, Count, is no doubt petitioning the Academy for a widening of your throat.
Marianne, how dare you insult the Count? Don't forget what the Count offers. Not just marriage, but think of how you will be introduced to all the salon. You will be the toast of Paris.
Would it not be a shame, madame, to burden you with the duties of matrimony before you have had a chance to experience your curiosity for nature?
Shall we all go through? It's getting rather hot in here.
You really plan to marry the Amara?
There is a plan, but it is not mine.
Then I must contrive to save you.
لم يكن لافوازييه عالما بالمعنى المهني، كان مدير تنفيذ الضرائب في باريس. كانت فكرته الكبيرة هي بناء سور ضخم حول المدينة وفرض الضريبة على كل ما يدخل أو يخرج منها، لكن ضرائبه على السلع البسيطة كالخبز والخمر والأجبان لم تجعله محببا لدى مواطني باريس العاديين. هذا الشاب المفرط الدقة والحساسية كان مع ذلك لا يحرم نفسه أحيانا من بعض الممارسات العاطفية. في عام 1771 تزوج لافوازييه من ماري آن بولز ابنة زميله في دائرة الضرائب، وبذلك أنقذها كما وعد من زواج معد مسبقا من كونت يكبرها ب40 سنة.
Allow me to show you something.
Lavoisier, I think, found his job as a tax collector really rather tedious, and the times he looked forward to were the evenings and the weekends when he could indulge his passion for chemical experimentation. And he called those times his jours de bonheur, his days of happiness.
Madame, what will happen if I take a bar of copper or iron and leave it outside in the rain for months on end? Madame Lavoisier.
Monsieur Lavoisier.
The methods. What will become of them?
Is this a verbal examination? Prior to an examination proper, sir?
You really seek the truth.
Then you join with me, monsieur, for you know the truth. The copper will become covered in a green verdigris, and the iron will rust. I believe the term is calcined.
Most impressive, my charming wife. But let me press you further. When a metal rusts, does it get heavier or lighter?
Why, sir, I think you mean to trap me.
Oh. And perhaps this little butterfly should land and allow me to take a closer look.
Every last citizen in France of sensible age knows that when a metal rusts, it wastes away, it gets lighter and eventually disappears. Stop. I have not finished. Contain yourself, sir. There is more. In a recently published pamphlet by a brilliant young chemist, Antoine Lavoisier demonstrates that the iron combines with the air. It, in fact, becomes heavier.
Most impressive. I intend.
Now, whatever you intend, monsieur, I intend to be by your side. I will learn all I can about your science and become your worthy colleague.
Then let me show you how the iron combines with the air to form such a delicate union.
Tomorrow, monsieur. Tomorrow.
تعلمت ماري آن الكيمياء قرب زوجها، لكنها بحثت عن وسائل مختلفة لتساعده في عمله. تعلمت الإنجليزية لتتمكن من ترجمة الكتب العلمية المعاصرة، وتابعت دروس الرسم لكي تسجل بتفصيل كل ما يعملانه معا. كانت تدير المختبر وتمثل مؤسسة لافوازييه في المجتمع. كانت محور جهود البحث العلمي.
That is a terrible thing to say. You are a cheeky man.
This way, please, gentlemen. Monsieur, it is my great ambition to demonstrate that nature is a closed system. That in any transformation, no amount of matter, no mass, is ever lost and none is gained. Over here, please. This precise amount of water is heated to steam. This steam is brought into contact with a red-hot iron barrel embedded in the coals. From this end, we cool the steam. But interestingly, we collect less water than we started with. So clearly, we lose a certain amount of water. However, we also collect a gas, and the weight of the iron barrel increases. Now, when we combine these two increases, the new weight of the iron barrel and the gas we have collected, they are exactly equal to the weight of the lost water.
But is it atmospheric air, Monsieur Lavoisier?
No, because I am measuring it to the very last grain. I can see that it is lighter than the air around us, and moreover, it is flammable. Voila.
Water is made out of hydrogen and oxygen. So what he had done is get the oxygen to stick to the inside of a red-hot iron rifle barrel. He was basically just making rust, which is oxygen and iron, but he was making the rust really quickly. Now that left the hydrogen, what he called combustible air, and that was just floating around as a gas. No mass had been lost, it had merely been transformed. And now he wanted to transform it all back into water.
This is only the beginning. In the next few months, I hope to demonstrate that I can recombine this combustible air with vital air
and transform them both back into water. I will recreate exactly the same amount of water that was lost here in this process. It is my hope to complete the cycle. Water into gas, into water. And not a drop lost.
For a long time, Lavoisier had suspected that the exact amount of matter, the mass, involved in any transformation was always conserved. But to prove this, he had to perform thousands of experiments. And he had to do the measurements with incredible accuracy. That's where his great wealth from being a tax collector came in. He could afford to commission the most sensitive instruments ever built. He became obsessed with accuracy.
لكن وسائل لافوازيه الصارمة في دقتها بدأت أيضا تثير غضب الباريسيين الجائعين المتذمرين.
Antoine? Antoine? Oh, wake up, Antoine!
Sorry. What time is it?
It is almost time to receive Monsieur Marat. The Academy asks you to assess his designs. He claims to have made a great discovery. Oh, Antoine, have you forgotten?
There's another charlatan with an idea to peddle. God give me patience. Monsieur Marat.
Monsieur, I have invented a device which projects an image of the substance of fire onto a screen. You see? When a lantern is shone through a flame, we see a shimmering pattern above the flame. My device renders the substance of fire visible.
Have you collected it, this substance of fire? Have you trapped it and measured it?
No, but one can see it.
I'm sorry, in the absence of exact measurements, of precise observations, without rigorous reasoning, one can only be engaging in conjecture, so this is not science.
I am not given to conjecture, monsieur.
Really, no. If you will excuse me, I am extremely busy today, but thank you. Thank you.
So that is all? Then good day, monsieur!
Let me guess, Marat. The King's scientific despot has decreed that your invention does not conform to the version of the truth as laid down by the Academy.
Lavoisier. He talks about facts. He worships the truth.
Listen to me, my friend. They are all the same, the Royal Academies. They insult the liberty of the mind.
They think they are the sole arbiters of genius. They are rotten to the core, just like every other tentacle of the king. The people. It is they who will determine right and wrong.
Don't worry. In my next pamphlet, I will expose this persecutor of yours.
طوال سنوات قامت جماعة لافوازيه بحرق وقص وصهر وغلي كل مادة في المتناول. بيّنوا أنه إذا كان المرء دقيقا في جمع كل الأبخرة والسوائل والذرور الناتجة عن عمليات التحويل فسيجد أن الكتلة لا تنقص. السوائل قد تتحول إلى غازات، والمعادن قد تصدأ، والخشب قد يصبح رمادا ودخانا، لكن المادة تلك الذرات الدقيقة التي تتشكل منها كل عناصر المادة لا تتبدد أبدا. وقد توج هذا الاكتشاف باستخدامهم المميز للكهرباء الساكنة لإعادة تركيب الأكسجين والهيدروجين كماء. عندما انفجرت الثورة الفرنسية تم إعدام العائلة الملكية ورموز الطبقة الأرستقراطية بالمقصلة.
To the French revolutionaries of 1790, Lavoisier meant one thing and one thing only. He was the despised tax collector who built that wall around Paris.
وظيفة لافوازيه كجامع ضرائب سلطت الشكوك حوله. لقد أدانه جان بول مارات العالم الفاشل الذي تحول إلى صحفي راديكالي.
Oui, Lavoisier.
Je sais pas.
Lavoisier. Lavoisier. Lavoisier.
What Lavoisier did is absolutely central to science, and especially T equals MC squared. Because what he said is if you take a bunch of matter, you can break it apart, you can recombine it, you can do anything to it, and the stuff of the matter won't go away. If the mob burned Paris to the ground, utterly razed it, shattered the bricks into rubble and dust, and burned the buildings into ashes and smoke, turns out if you put a huge dome over Paris and weighed all the smoke and all the ashes and all the rubble, it would add up to the exact same weight as the original city and the air around it before. Nothing disappears.
بعد قرن من ذلك الزمن تم تصنيف الطبيعة إلى نوعين: الطاقة، القوى التي تحرك الأشياء، والكتلة، وهي المواد التي تتشكل منها تلك الأشياء. علوم القرن التاسع عشر كلها استندت إلى هذين التصنيفين الأساسيين. القوانين التي كانت تحكم أحدها لم تكن تنطبق على الآخر، لكن اينشتاين الشاب حديث العهد بالفيزياء لم يكن يحب القوانين.
What happened to you?
It is more than a little ironic, having been reprimanded yesterday by that idiot Professor Pernay for poor attendance, that I should in fact attend a practical lesson, which was, as long as it was boring and utterly pointless, by the way, only to be the victim of an explosion of my own apparatus.
So it was your own fault then?
Thank you. And how are you today, Fraulein Manage?
Extremely well, Herr Einstein. All the better for seeing you have escaped the physics laboratory with your life.
Well, in order not to alarm you any further, I pledge to forever continue my studies here at the Café Bahnhof, reading only the great masters of theoretical physics and eschewing the babbling nonsense of the polytechnicians.
It's about all you ever do.
It's getting a little stuffy in here, Fraulein Marriage. Would you care to take a walk with me? There's something I'd like to discuss with you.
Why, Herr Einstein? Of course. Perhaps you'd like me to tell you what you have missed in lectures this week.
Einstein wasn't exactly a model student. He excelled in certain subjects, especially physics and math, but he wasn't very diligent in a lot of his other classes. He was undoubtedly very questioning, which seems to have annoyed most of his professors throughout his life. He would pursue his fascinations with just incredible determination.
We know from his letters that Einstein, even from the age of 16, was literally obsessed with the nature of light. Everyone he could speak to, his friends, his colleagues, even his then girlfriend, Mileva Merrick, who had become his wife, everyone he badgered with the question, what is light?
What would I see if I rode on a beam of light?
What? A beam of light? By what method do you propose to ride on this beam of light?
The method is not important. Let us just imagine me to a young, radical, bohemian experimenters, hand in hand on a journey to the outer reaches of the universe, and we are riding on the front of a wave of light.
I really don't know what you are suggesting, Herr Einstein. Do you wish to hold my hand or ridicule me?
Ridicule you? No, never. I merely want you to help me to understand. What would we see, do you think, if we were together and we sped up
and up until we caught up to the front of a beam of light.
الملاحقة المستمرة للضوء التي شغلت اينشتاين هي التي أحدثت ثورة في العالم. بالضوء أعاد تركيب النظرة إلى الكون وعثر على العلاقة التي تربط بين الطاقة والكتلة. الضوء يتحرك بسرعة تبلغ 670 مليون ميل في الساعة، لهذا استخدم العلماء حرف السين للدلالة على السرعة. قبل حلول القرن التاسع عشر بفترة غير قليلة استطاع العلماء رصد سرعة الضوء، لكن أحدا لم يكن يفهم ماهيته. في إنجلترا استطاع رجل أشرنا إليه سابقا تقديم تخمين مدروس. بعد وفاة السير هامفري ديفي أصبح مايكل فاراداي البروفيسور فاراداي أحد أهم الذين أجروا التجارب في العالم. كانت المؤسسة العلمية لا تزال ترفض فكرة أن الكهرباء والطاقة المغناطيسية إن هما إلا مفهومان لظاهرة واحدة سماها فاراداي الكهرومغناطيسية. مع ذلك كان عليه أن يقدم عرضا أكثر إثارة لجمهوره.
Invisible lines that can emanate from electricity in a wire, from a magnet, or even from the sun. For it is my contention that light itself is just one form of these vibrating lines of electromagnetism.
بذل فاراداي جهده طوال 15 سنة لإقناع المشككين بأن الضوء هو موجة كهرومغناطيسية، لكنه كان يفتقر إلى الرياضيات المتقدمة لدعم رأيه. أخيرا جاء من يؤازره. البروفيسور جيمس كلارك ماكسويل آمن بصحة رؤية فاراداي البعيدة النظر، وكان لديه الطريقة الرياضية لإثباتها. وهكذا أصبح ماكسويل والعجوز فاراداي صديقين حميمين.
James, forgive me. A word of advice. Don't get over it. Michael, how are you? I'm fine. Memory isn't too good. Well, I thought you might like to see what I've just published. Oh, yes. Yes. Splendid. So your results show that when electricity flows along a wire, what it actually does is create a little bit of magnetism. And as that magnetic charge moves, it creates a little piece of electricity. Electricity and magnetism are interwoven, like a never-ending braid. So it is always pulsing forward. It's wonderful. Wonderful. Michael, there's something very crucial in maths. This electricity producing magnetism and magnetism producing electricity, it can only ever happen at a very particular speed. The equations are very clear about it. They come up with just one number. 670 million miles per hour. I'm not sure. It's the speed of light. That is the speed of light. But you were right all along. Light is an electromagnetic wave.
أثبت ماكسويل أن فاراداي كان محقا. الكهرباء والمغناطيس هما مظهران لوحدة أعمق، لقوة تدعى اليوم الكهرومغناطيسية، تنتقل بسرعة 670 مليون ميل في الساعة. أما بشكلها المرئي فهي ليست أكثر من الضوء نفسه.
She's very pretty.
Yes. But can she soar and dance like our dark souls do?
Maxwell's equations contained an incredible prediction. They said you could never catch up to a beam of light. Even if you were traveling at 670 million miles an hour, you would still see light squiggle away from you at 670 million miles an hour.
you see how she stares at that wave?
Yes?
You see how for her it is static?
Yes?
She and the wave are traveling at the same speed. We see the wave moving through the water, but relative to her, it just sits there. So is light like that?
Common sense would say that if you caught up to a light beam, there would be a wave of light just sitting there. Maybe it would be shimmering, a bit of electricity and a bit of magnetism.
So, if she was traveling alongside the light wave, it wouldn't be moving, it would be static. But Maxwell says you can't have static light.
Maybe Maxwell is wrong. Maybe if you catch up to light, it is static, Albert, like a wave next to a boat.
Imagine if I was sitting still and holding a mirror to my face. And the light travels from my face to the mirror, and I see my face.
Yes?
However, if I and the mirror were traveling at the speed of light...
You're going at the same speed as the light leaving your face.
Exactly.
The light never reaches the mirror.
So would I be invisible?
That doesn't make sense.
كان اينشتاين الشاب قد بدأ يدرك أن الضوء لا يشبه أي نوع من أنواع الموجات. كان على وشك دخول عالم تتداخل فيه الطاقة والكتلة وسرعة الضوء بطريقة لم تخطر في بال أحد، لكن كان هناك جانب رياضي يحتاج اينشتاين إليه، وهو عملية التربيع الرياضية اليومية. قبل الثورة الفرنسية بزمن طويل لم يكن العلماء يعرفون كيف يقيسون الحركة. كانت المعادلات التي تشرح حركة الأشياء واصطدامها بدائية. أما المساهمة الهامة في هذا الموضوع فجاءت من مصدر غير متوقع. أعرفكم بالأرستقراطية، ابنة أحد رجال حاشية الملك لويس الرابع عشر، إيميلي دو شاتلي. إيميلي دو شاتلي كان لها تأثير كبير في الفيزياء خلال حياتها القصيرة. تلك المرأة التي لم يسمع بها أهل زمنها نشرت عددا من البحوث العلمية، من بينها ترجمة مؤلف إسحاق نيوتن المبادئ، وهو أعظم بحث حول الحركة كتب يوما. ما زالت ترجمتها نصا نموذجيا في فرنسا حتى هذا اليوم.
In one sense, she is a woman utterly out of her true time and place. She's a philosopher, a scientist, a mathematician, a linguist. She demands a freedom that women didn't begin to enjoy until over 150 years later. A freedom to study science, to write about it, and to be published.
تزوجت إيميلي في 19 من عمرها من جنرال في الجيش الفرنسي وأنجبت 3 أطفال. كانت تدير منزلا متطلبا وتعتني باهتماماتها العلمية. كانت في 23 عندما اكتشفت الرياضيات المتقدمة. كانت تحضر دروسا عند أبرز علماء الرياضيات في ذلك الوقت وهو بيير دو موبرتوي. كان خبيرا بنيوتن وكانت هي التلميذة الصغيرة الشغوفة، لكنه سرعان ما انطلق في رحلة استكشاف قطبية. بعد ذلك تعلقت إيميلي بفولتير أبرز شعراء فرنسا، ولأنه كان ناقدا حادا للملك والكنيسة الكاثوليكية أدخل إلى السجن مرتين ثم نفي إلى إنجلترا حيث سحر بأفكار نيوتن. وعندما رجع إلى فرنسا عاود الإساءة إلى الملك، لكن إيميلي أخفته في بيتها الريفي. بعيدا عن باريس حولت إيميلي وفولتير قصرها إلى مكان للعلم والثقافة مع مسرح صغير، وكل ذلك بمباركة وتشجيع زوجها.
There's a great deal of myth surrounding Du Châtelet and her love life, and most of it is very exaggerated. But her husband did accept Voltaire into his household, and he often went to Paris on behalf of Voltaire. He went to his publisher to plead Voltaire's case, to keep Voltaire out of jail. And it is also true that Emily Du Châtelet did have several affairs of a fleeting nature.
Bravo, bravo! She created an institution to rival that of France's Royal Academy of Sciences. Many of the great philosophers, poets, and scientists of the day visited.
Oh, monsieur, you are young. I hope that soon you will judge me for my own merits, or lack of them. But do not look upon me as an appendage to this great general, or that renowned scholar. I am in my own right a whole person, responsible to myself alone. for all that I am, all that I say, all that I do.
لقد تعلمت إيميلي من الرجال النوابغ حولها، لكنها سرعان ما أبدعت أفكارها الخاصة بها. أثارت ذعر معلميها عندما تجرأت على الإشارة إلى وجود عيب في تفكير السير إسحاق نيوتن. أكد نيوتن أن طاقة الأشياء أو القوة التي تجعلها تتصادم يمكن حسابها ببساطة من خلال ضرب كتلتها بتسارعها. ومن خلال المراسلة مع علماء ألمان تعرفت إيميلي إلى رأي آخر، رأي غوتفريد لايبنيز، الذي قال إن للأشياء نوعا من الروح الداخلية، الطاقة الذاتية، سماها فيس فيفا، وهي كلمة لاتينية تعني القوة الحية. كان الكثيرون يستخفون بآرائه، لكنه كان مقتنعا أن طاقة الجسم مكونة من كتلته ضرب مربع سرعته.
Taking the square of something is an ancient procedure. If you say a garden is 4 square, you mean that it might be built up by 4 slabs along one edge and 4 along the other. So the total number of paving slabs is 4 times 4, 16. If the garden is 8 square, 8 by 8, well, 8 squared is 64. It'll have 64 slabs in it. This huge multiplication, this building up by squares, is something you find in nature all the time.
Emily, you are being absurd. Why ascribe to an object a vague and immeasurable force like vis viva? It is a return to the old ways. It is the occult!
When movement commences, you said it is true that a force is produced which did not exist until now. Think of our bodies. To have free will, we must be free to initiate motion. So all Leibniz is asking is, where does all this force come from?
In your case, my dear, the force, I am sure, is primeval.
Oh, you're infuriating. You hide behind wit and sarcasm. You only think you understand Newton. You're incapable of understanding Leibniz. You're a provocateur. Everything you do is about something else and makes trouble for you. Criticize this, denounce that. Are you capable of discovering something of your own?
I discovered you!
على الرغم من التأييد الواسع لنيوتن، فإن قناعة إيميلي دو شاتليه لم تتزعزع. وفي النهاية عثرت على تجربة قام بها عالم هولندي يدعى ويلم سيغرافيساند أثبتت وجهة نظرها.
Strafsound in Leiden has been dropping lead balls into a pan of clay.
Dropping lead balls into clay? How very imaginative.
Using Newton's formulas, Monsieur Voltaire, he then drops a second ball from a higher height, calculated to exactly double the speed of the first ball on impact. So, Monsieur, care for a little wager? Newton tells us that by doubling the speed of the ball, we will double the distance it travels into the clay. Leibniz asks us to square that speed. If he is correct, the ball will travel not 2, but 4 times as far. So, who is correct?
Monsieur, I feel Mr. Newton's reputation dwindling ever so slightly.
Oh, Maupertuis, do not succumb to her. There is no earthly reason to ascribe hidden forces to this Dutchman's lead balls.
Well, the ball travels 4 times further.
Turns out, Leibniz is the one who was right. It's the best way to express the energy of a moving object. If you drive a car at 20 miles an hour, it takes a certain distance to stop if you slam on the brakes. If you're going 3 times as fast, you're going 60 miles an hour, it won't take you 3 times as long to stop. It'll take you 9 times as long to stop.
Oh, well, it does seem worth consideration.
Perhaps we might look over his calculations.
I have already checked his figures. I am sure Leibniz is correct on this point. I intend to include a section on this matter in my book.
Really? Do be careful, madame. Do you think the Academy is ready for such an opinion?
Quite. We really should be careful.
We? I see no reason to delay. There is no right time for the truth.
Emily du Châtelet published her Institutions of Physics in 1740, and it provoked great controversy. Voltaire wrote that she was a great man whose only fault was being a woman. In her day, that was a great compliment.
I am with child.
You are sure?
Undoubtedly. 2 to 3 months. I'm afraid that.
You are afraid? You should... Well, this child is obviously not mine. Nor is it your husband's. Oh, Emily.
Emily de Châtelet knew that in the 18th century, for a woman to become pregnant at the age of 43 was really very dangerous. And all the while she was pregnant, she had terrible premonitions about what was going to happen.
كانت إيميلي طوال حياتها تحاول تجاوز الحدود المفروضة على بنات جنسها. في النهاية، بعد زواجها من جندي شاب وبعد 6 أيام من ولادة طفلها الرابع، أصيبت بانسداد وعاء دموي وتوفيت. أثارت نظرية إيميلي أن طاقة الجسم معادلة لمربع سرعته جدلا حادا. لم يتم قبول فكرتها إلا بعد 100 عام من وفاتها، وذلك عندما جاء اينشتاين واستخدم هذه الفكرة الملهمة لجمع الطاقة والكتلة مع الضوء. راح اينشتاين يطارد الضوء خلال وبعد المرحلة الجامعية. لسوء الحظ كان يضايق أساتذته إلى حد أنهم جميعا رفضوا إعطاءه تزكيات. لقد قبل بوظيفة قليلة الأجر في مكتب تسجيل براءات الاختراع السويسري. تزوج ميليفا وأنجب منها طفلا وكافحت العائلة الصغيرة، لكن ذلك كله لم يضايق ألبرت.
Einstein, I see you are busy, as usual. Look, Einstein. You have shown some quite good achievements, but listen, about your promotion. I really think it would be better to wait until you have become more fully familiar with mechanical engineering. I'm sorry. Perhaps next time.
But I wanted to hire a maid so I can get back and finish my degree. Now I will never pass my dissertation.
Oh, come, my pretty little duck. All will be fine. You'll see.
How will it be fine, Albert? Do I have to just wait another year until you are promoted? Come on. Oh.
All will be fine. All will be fine. You'll see.
There really is a very charming but kind of a self-centered streak to Einstein. He focuses only on his particular obsessions. If the rest of the world fits in around him, that's fine. If they can't, it doesn't bother him.
And he's going to come and tell us. Albert, a pretty neck and your head spins.
Okay, so we must behold and comprehend the mysterious.
Well, that kind of mysterious is going to get you into trouble.
I'll tell you what is truly mysterious. The secret of a long and happy marriage.
The mathematics are fine, if a little unconventional, but this only works for big systems. It'll fall down when you apply it to small systems.
I disagree.
Oh, no. Here we go. Another grand theory by Herr Albert Einstein, a patent clerk, that class.
What would happen if one applied those formulae to electromagnetic radiation?
Albert, you can't just take one bit of physics and apply it without proper regard to a completely different area.
Why not?
Albert, I know you like the grand linkages, the big theories, but wouldn't things be better all round if you just got going in some small area? Got a university post, get a decent wage, for God's sake. At least Mileva could study again. Then she'd be happy, and you'd be happy.
Ah, the vulgar struggle for survival. Food and sex. Spoken like a true bourgeois. Listen, I want to know how God created this world. I'm not interested in this or that phenomenon, in the spectrum of this or that element. I want to know his thoughts. The rest? The details.
Yes, but you can't feed your children on his thoughts, Bertie.
So it turns out Einstein was going for a walk with his very close friend Michel Besso. They'd studied physics together and talked about physics and philosophy for years and years. They were very close. They had cornered the question of light from every possible angle.
See this clock over here?
بينما كان أينشتاين وبيسو يتساءلان كم يستغرق الضوء ليصل إليهما من ساعات بمختلف المسافات، لمعت في رأس أينشتاين رؤية هامة.
Thank you. Thank you. I have completely solved the problem.
Albert!
What Einstein did was completely turn the problem on its head. Other scientists had found it impossible to accept Maxwell's idea that light would always move away from you at 670 million miles an hour, even if you too were traveling really fast. But Einstein just accepted that as a fact. Light's speed never, ever changes. Then, what he did was bend everything we know about the universe to fit light's fixed speed. What he discovered was that to do that, you have to slow down time.
His extraordinary insight is that time, as you approach the speed of light, time itself will slow down. It's a monumental shift in how we see the world.
The very instant when Einstein had this brilliant insight that time could slow down, well, the floodgates began to open. You see, before then, people had assumed that time was like a wristwatch on God's hand, that it beat at a steady rate throughout the universe, no matter where you were. Einstein said no, that the tick, tick, tick of this wristwatch was actually the click, click, click of electricity, turning into magnetism, turning into electricity. In other words, the steady pace of light itself.
"1905 was a miraculous year for Einstein and for physics. He had an unbelievable outpouring of creativity. It starts with his publication of a paper on how to work out the true size of atoms. 2 months later is the publication of his paper on the nature of light. That's what we'll learn of the Nobel Prize. The third paper, only a month later, is on how molecules move when heated, and that finally ends the debate on whether atoms really exist. The fourth paper is published at the end of this half-year period. In it, Einstein sets out his theory of light, time, and space. It was the theory of special relativity. That changed the way we see the world.
في عالم أينشتاين الجديد، الثابت الوحيد لم يكن الزمان ولا المكان، بل الضوء. لكن عام أينشتاين المشهود لم ينتهي. في آخر بحث كبير نشره عام 1905 قدم أينشتاين وحدة أعمق. في أثناء حسابه لكل التعقيدات في نظريته لاحظ علاقة غريبة أخرى، علاقة بين الطاقة والكتلة والضوء.
Einstein realizes that the speed of light is kind of like a cosmic speed limit. Nothing can go faster. So imagine we have a train charging along, and let's say it's getting up to the speed of light, and we're stuffing more and more energy in, trying to get it to go faster and faster. But it's still bumping up against the speed of light. So all this energy, where does it go? It has to go somewhere. Amazingly, it goes into the object's mass. From our point of view, the train actually gets heavier. The energy becomes mass. It's an incredible idea. Even Einstein is amazed by it.
I think I have found a connection between energy and mass, if I am right. Then energy and mass are not absolute. They are not distinct. They can be converted into one another. Energy can become mass, and mass can become energy. And not just energy equaling mass. Energy equals mass times the square of the speed of light.
Would you like me to check your mathematics?
أرسل اينشتاين ورقته الخامسة عام 1905 للنشر. ب3 صفحات فقط أوضح أن الطاقة والكتلة تربطهما علاقة مربع سرعة الضوء E يساوي MC مربع. ب4 نقطات في سلم الطبيعة تمكن موظف براءة الاختراع هذا من تأليف لحن جديد كان حصيلة سنواته العشر في رحلته مع الضوء.
Here we are for thousands of years thinking that over here is a world of objects, of matter, and over there is an entirely separate world of movement, of forces, of energy. And Einstein says, no, they're not separate. Energy can become mass, and crucially, mass can also become energy. There's a deep unity between energy, matter, and light.
E equals mc squared. That equation shows that every piece of matter in our universe has stored within it a fantastic amount of energy. The speed of light, for example, is about 300 million meters per second. You multiply that by itself, and you get 90 quadrillion. So in other words, what is matter? In some sense, matter is nothing but the condensation of vast amounts of energy. So in other words, if you could somehow unlock all the energy stored within my pen, that would erupt with a force comparable to an atomic bomb.
After Einstein's fifth great 1905 paper, physicists no longer spoke of mass or energy. They're now the same thing to us.
لعل أعظم سنة بالنسبة إلى العلوم الإنسانية قد انتهت إلى الصمت المطبق. لقد نشرت المقالات من دون أن تعطي أي صدى. ثم بدأت الأمور تتحرك. رسالة هنا، ورقة هناك. طوال 4 سنوات راح أينشتاين يجيب على كل تساؤل بجدية وأمانة، محاولا شرح أفكاره الصعبة والمعقدة لعلماء الفيزياء.
I love the idea that life just went on as normal. Here are these universe-changing papers circling around, and the world is struggling to come to terms with them.
Einstein had a fan club of just one. Luckily, it happened to be the most important living physicist.
Einstein. Max Planck has sent someone to see you.
Max Planck?
Yes, he has sent his assistant. He's here to see you.
ماكس بلانك أبرز الفيزيائيين حتى على التعامل مع أينشتاين بجدية. بعد 4 سنوات من الانتظار عين أستاذا للفيزياء في جامعة زيورخ، ومن هناك انطلقت شهرته. نصب أستاذا للفيزياء في برلين ليحقق شهرة عالمية ويصبح علما في بلاده. لقد غدا أبا الفيزياء المعاصرة بلا منازع. لكن نجاح أينشتاين أدى إلى فشل زواجه. في عام 1919 طلق ميليفا وتزوج ابنة عمه. أصبحت معادلة الطاقة تساوي الكتلة ضرب مربع سرعة الضوء، الكأس المقدسة للعلوم. لقد أنبأت بمخزون الطاقة الهائل الكامن في الذرة. ظن أينشتاين أن سبرها سيستغرق 100 سنة من البحوث، لكنه لم يتوقع أن يتم سبرها خلال الحرب العالمية الثانية في ألمانيا الهتلرية. كانت ليزا مايتنر النمساوية ذات 28 ربيعا امرأة خجولة جدا. على الرغم من قلقها وصلت دكتورة الفيزياء الشابة إلى برلين وهي مصممة على الحصول على عمل في حقل النشاط الإشعاعي المثير، لكن لسوء الحظ لم تكن جامعات ألمانيا عام 1907 توظف النساء الخريجات. لكن ولحسن الحظ كان هناك من وقف إلى جانبها.
Fräulein Meitner.
Yes?
Otto Hahn. I'm a researcher in the Chemistry Institute. Professor Planck suggested I...
Herr Hahn, I have read your papers on thorium and on mesothorium, and Dr. Planck suggested that
Yes, he suggested that I speak with you. I need someone to collaborate.
I think I could really help with the physical analysis.
And the mathematics.
Yes, and the mathematics.
Studying radioactive atoms has become so much a collaboration between chemistry and physics these days.
Yes.
I'll ask Fischer for a laboratory then.
Excellent.
I'll speak to you soon.
قامت ليزا مايتنر بأول خطوة في رحلة سوف تغير تاريخ العالم بالتأكيد. بالنسبة إليها سيكون طريقا مفروشا بالنجاح والشهرة، ولكن أيضا محفوفا بالخوف والخيانة.
At this time, not a lot was known about the atom. At first, people thought it was like a miniature solar system. There was a solid nucleus at the center, and electrons would spin around it, sort of like planets around our sun. A little later, some researchers proposed that the nucleus itself wasn't a solid chunk, but was made up of separate particles of protons and neutrons. But then, in what are called radioactive metals, things like radium and uranium, the nucleus itself seemed to be unstable, leaking out energy in particles. Perhaps this was an example of equals mc squared, the mass of a nucleus turning into energy.
تعاون مايتنر وهاهن في فك أسرار الذرة بدأ بظروف غير متساوية. فقد قدم له مختبر، أما هي فأرغمت على العمل في مستودع للأخشاب.
I see you haven't set your hair on fire.
Herr Hahn?
The boss, he thinks that if he lets women into the Chemistry Institute, they'll set their hair on fire.
Oh, so his beard must be fireproof.
Good day, Herr Hahn. Good day.
You see, I'm non-existent to this place. At least physicists recognize me for my abilities.
Yes, where would we chemists be without the steadying hand of the physicist?
It took years, but Lisa lost her shyness eventually. In 1912, she and Hahn moved to the brand new Kaiser Wilhelm Institute for Chemistry, where their status was really that of equals. Lisa became the first woman in Germany ever to have the title of professor.
Lisa, I muse. Remember the art student I told you of?
Yes, Edith.
Yes, well, I have asked her to marry me, and she has accepted.
Oh, Dr. Hahn, congratulations.
Yes, well, I wanted you to be the first to know.
I'm very pleased for you. Very pleased.
Lisa Meitner was warm-hearted by nature. She had many friends, and she may have wanted to have a closer relationship with Otto, but it really does seem that physics was Lisa's first love, maybe even her passion.
كانت العشرينيات والثلاثينيات السنوات الذهبية للبحوث النووية. أشهر نواة في تلك الفترة كانت نواة اليورانيوم التي تحتوي على 238 بروتونا ونيوترونا. كانت مايتنر وهاهن يتصدران المتسابقين حول معرفة إمكانية تشكيل نواة أكبر بإضافة مزيد من النيوترونات.
The atom, pretty familiar. Nucleus in the center, electrons orbiting around. The nucleus is our focus. The nucleus made up of protons
and neutrons. Now, the largest nucleus that we know is that of the uranium atom. Its nucleus is a tightly packed structure of 238 protons and neutrons. The thrust of our work is to try to fire neutrons into this huge structure, and if we can get a neutron to stick in here, it will be a breakthrough.
كانت مايتنر على وشك التوصل إلى اكتشاف كبير، لكن ألمانيا في الثلاثينيات كانت مكانا خطرا حتى على عالم من الدرجة الأولى.
The US endangers our institute.
When the Nazis came to power, one of the first things they did was to drive out Jewish academics from the universities. Einstein was very prominent, and for that reason he was one of the first to go. He was hounded out of Germany in 1933. Lisa was not dismissed at that time. She was able to stay because she was Austrian. But in March 1938, Austria was annexed into Germany, and at that point her situation became untenable.
What is it?
Frightening news.
What's happened?
Kurt Hess is going around saying that I should be got rid of.
I actually knew. I heard today I was going to speak to the treasurer of the institute before I told you. We'll speak to him tomorrow. Come on, let's get you home. It's late. We'll finish up.
كان الضغط على مايتنر لا يحتمل. هاهن الذي عرف بمعاداة الأفكار النازية بذل جهده لحمايتها من حيث المبدأ على الأقل.
I need to talk to you about Lisa. Not now, I'm too busy. We have to protect her.
How? What can we do? The situation is the way it is. Who knows what will happen next? She can't stay. It's just not tenable.
But she hasn't got a visa or even a valid passport. And she may soon be forbidden to leave Germany.
We can't harbor a Jew. If she stays, the regime will shut us all down.
Lisa. Orline demands that you leave.
You can't throw her out.
Orline says you should not come into the institute anymore.
Well, I have to write up then. Thorium irradiation tomorrow, so I have to come in.
You've given up.
عندما تبين أن مايتنر قد تطرد أو تعتقل، راح الفيزيائيون في أنحاء أوروبا يدعونها لمؤتمرات مقدمين لها مبررات للخروج من ألمانيا. رفض النازيون السماح لها بالخروج. في تموز عام 38 ذهب أحد زملائها الهولنديين إلى برلين وهربها معه في قطار إلى هولندا. كانت الرحلة مرعبة إلى درجة أنها في لحظة ما توسلت إليه أن يعيدها، لكن على الرغم من الخطر المحدق تمكنت من العبور.
She had lost everything: her home, her position, her books, her salary, her pension, even her native language. She had been cut off from her work just at the time when she was leading the field and was on the brink of a major scientific discovery.
لم تكترث ليزا بالحرمان الذي عانته، كان بالها لا يزال مشغولا بالفيزياء، والمدهش أنها تمكنت وهاهن من التعاون عبر الرسائل.
I hope, my dear Otto, that after 30 years of work together and friendship in the Institute, that at least the possibility remains that you tell me as much as you can about what is happening back there.
Lisa was invited by an old student friend to spend Christmas on the west coast of Sweden. Her nephew, Otto Robert Frisch, who was also a physicist, came to join her there.
Aunt? 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 Lisa, how are you, my dear? Merry Christmas, Aunt.
I need your help. Come on, let's go out.
But I was hoping you'd help me.
في برلين كان هاهن يحقق نتائج غريبة. لم يجد ما يؤكد الاعتقاد بأن قصف نواة اليورانيوم بالنيترونات يؤدي إلى زيادة حجمها. في الواقع بدت تجاربه وكأنها تلوثت بالراديوم الذرة الأصغر حجما. كان بحاجة إلى خبرة مايتنر بالتحليل. وعن بعد شعرت مايتنر بأن شيئا مختلفا تماما يحدث في تجاربهما.
Hahn and Strassman are getting some strange results with the uranium work.
Really?
A couple of months ago, Hahn told me that they were finding radium amongst the uranium products. We are looking for a much bigger element, and here we're finding something much smaller. I urged Hahn to check again. It couldn't be radium. And now he writes to me and tells me that it's not radium, it's barium.
That's even smaller.
Exactly. Hahn is sure that it's another error, but I don't know anymore. It is at least possible that barium is being produced.
So Hahn still needs you to interpret the data.
It is my work too, you know.
Exactly.
Well, I can't be there, can I? Come on, let's walk.
Surely he's made a mistake, hasn't he? He hasn't done what you told him to.
Oh, my darling Robert, he may not be a brilliant theorist, but he's too good a chemist to get this wrong.
If you imagine a drop of water, a big drop, it's unstable, on the verge of breaking apart. It turns out that a big nucleus like uranium is just like that. Now, for 4 years, Meitner and Hahn and all other physicists had thought that if you pump more neutrons into this nucleus, it'll just get bigger and heavier. But suddenly, Meitner and Frisch, out in the midday snow, realized this nucleus might just get so big that it would split in two.
If the nucleus is so big that it has trouble staying together, then couldn't just a little tiny jog from a neutron...
Yes, but if the nucleus did split, the two halves would fly apart with a huge amount of energy. Where's that energy going to come from?
How much energy?
Well, we worked out that the mutual repulsion between two nuclei would generate about 200 million electron volts. But something has to supply that energy.
Wait, let me do a packing friction calculation. The two nuclei are lighter than the original nucleus of the uranium by about 1/5 of a proton in mass.
What? So some mass has been lost. Einstein's E equals mc squared.
If we multiply the lost mass by the speed of light squared, we get 200 million electron volts. He split the atom.
No. You've split the atom.
It was an amazing discovery. Of course, in the laboratory, we're talking about tiny amounts of uranium and correspondingly tiny amounts of energy. But the point is that the amount of energy released was relatively large, and that came from the mass of the uranium itself. The energy released was entirely consistent with Einstein's equation E equals mc squared.
نشر فريش ومايتنر اكتشافهما الذي سمياه الانشطار النووي، لكن الخيانة كانت في انتظارهما، إذ تعرض أوتو هاهن لضغط من النظام النازي لاستثناء زميلته في البحث لعدم يقينهم من ولائها. وحده حصل على جائزة نوبل لعام 44 على الاكتشاف، ولم يكد يذكر دور مايتنر الهام في الكلمة التي ألقاها. وبعد الحرب زعم هاهن أنه هو وليس مايتنر من اكتشف الانشطار النووي.
Now I want to write something personal, which disturbs me and which I ask you to read with more than 40-year friendship in mind and with the desire to understand me.
I am now referred to as Hans' long-time co-worker. How would you feel if you were only characterized as the long-time co-worker of me? After the last 15 years, which I wouldn't wish on any good friend, shall my scientific past also be taken from me? Is that fair? And why is it happening?
Lisa Meitner had been working on this for 30 years. She'd only broken apart a handful of atoms, but that was enough. Once she had broken even one, the genie was out of the bottle. What Meitner had started, after that, physicists around the world began to realize they could take it a lot further.
في عام 42 بدأت الجهود تبذل لصنع القنبلة النووية. في أنحاء أمريكا كان يجري تركيب المنشآت تحت اسم سري هو مشروع مانهاتن.
Meitner was asked to join the Manhattan Project, and she refused. She refused to have anything to do with the atomic bomb. But Robert Frisch was different. He was an important member of the team because he was convinced of the need to beat the Nazis in a nuclear arms race.
لم تستخدم القنبلة النووية ضد ألمانيا، لكن القنبلتين اللتين ألقيتا فوق هيروشيما وناكازاكي عبرتا عن القوة التدميرية الكامنة في معادلة الطاقة تساوي الكتلة ضرب مربع سرعة الضوء. تم تحرير كميات هائلة من الطاقة على شكل إشعاع كهرومغناطيسي من بضعة كيلوغرامات من اليورانيوم والبلاتينيوم. إن كانت بحوث أكثر علماء الدنيا موهبة قد أدت إلى اختراع سلاح دمار شامل، لكن المعادلة نفسها كان لها حكاية موازية تتصف بالإبداع والجمال. اليوم يحمل فيزيائيون شباب رسالة اينشتاين، ومنذ ولادتها يجري استخدام المعادلة الشهيرة للغوص في أعماق الزمن للإجابة عن أعظم الأسئلة: من أين أتينا؟ في مسرعات الجسيمات دفع الباحثون مكونات الذرة باتجاه سرعة الضوء وصدموها معا لتخلق ظروفا أشبه بظروف الانفجار الكبير.
E equals mc squared actually tells us how the Big Bang itself happened. In the first moments of creation, the universe was this immensely dense, immensely concentrated eruption of energy. As it rushed apart and expanded, huge amounts of energy, or E, were converted into mass, or M. Pure energy became matter. It became the particles and atoms, and it eventually formed the first stars.
Our sun is a huge furnace floating in space, and it's powered by equals mc squared. Now it turns out every second 4 million tons of solid mass of the sun disappears, comes out as energy, not just a little bit of energy. It's enough to light up our entire solar system, make the solar system glow with heat and light.
And not only do stars emit energy in accordance with E equals mc squared, the whole process actually creates life itself. Eventually, a massive star dies, the debris floats around, clusters together, gets pulled into the orbits of another star, and becomes a planet. We, humans, and the Earth we stand on are made of stardust. We are a direct product of E equals mc squared.
إن جيلا جديدا من الباحثين يبحث عن إجابات بالاستفادة من تجارب العلماء عبر العصور. باستخدامهم أدوات جديدة تبلغ سرعتها سرعة الضوء تقريبا، بات في وسعهم إثارة أسئلة لم يتسنى لأسلافهم حتى تخيلها. كان اينشتاين يعرف أن رحلة الاكتشاف مؤلمة أحيانا ومفرحة أحيانا أخرى. إنها قديمة قدم الفضول البشري ولا تتوقف أبدا.